Hi students, this is Neeraj Bansal and welcome back to my channel Math Navigator. Today we are going to talk about discrete random variable, which is part of statistics and probability, right? So let's talk about discrete random variable, right? As the name suggests, discrete, we know we have two types of variables, that is the discrete and continuous, right? Discrete is something which takes fixed value. And as we already know, what is random? Random is like something which is generated by the random experiment. Random experiment, but which means it is not pre-planned what my result will be, right? Like tossing a coin. So when I'm tossing a coin, I'm not sure whether it will be head or a tail, right? So that is called discrete random. And variable is something which changes. So I'll take a simple example. See what I'll take a simple example of an event. But in order to understand, I'll give you a little bit idea what is a discrete random variable. Discrete random variable is something what you define. I'll give you an example. Let's say if I toss coin 2 times, right? So how can I define my discrete random variable? I'm defining my discrete random variable x is equal to number of heads obtained. What does this mean? This means, let's say if I'm tossing a one coin, right? So it can be a head or a tail. I'm tossing the another coin, it can be a head or a tail. So it is possible that on both the coins I have tails, so it is zero head. On one of the coins I have a head and one of the coins I have tails, so one head. And on both the coins I have head, so it is two heads. So my x can be 0, 1 or 2. Got it? Then what I need to do? I need to find the probability of getting 0 heads, 1 head and 2 head. As I've told you, the main thing in statistics and probability is how you will find the probability. You will be requiring it everywhere. So x is my discrete random variable, which is number of heads. Now this is one of the columns, and now I will find probability of x. That means probability of getting a 0 head, 1 head or 2 head. Normally what students make a mistake is probability of head is half, which is not correct. When I'm saying 0 head, that means probability of getting 2 tails. When I'm saying 1 head, that means one is head, one is tail. And when I'm saying both are heads, that means both are heads. So I'll use a tree diagram to find the probability, right? Let's make it. Or I can use a two-way table as well. So it can be a head or a tail. It can be head or a tail. It can be a head or a tail. So this is head head. This is head tail. This is head tail only. And this is tail tail. So probability of 0 head is half. And probability of 1 head is half plus half, which is half plus half, which is, sorry, I'm so sorry. Probability of 0 heads is 1 by 4. Probability of 1 head is 2 by 4. And probability of this is, why I have not cut by 1 and 2, I'll tell you. See, basically the total probability always stays 1. So if I do 1 over 4 plus 2 over 4 plus 1 over 4, which is equal to, right? So this table is called distribution table, or you can call it probability distribution. Clear? So how will you find the mode? Mode is the highest probability. So in this case, my mode is 1. And median is the middle value. So if you have the probability, then you can find it. How do we find it? We will, when we'll do the question, you will understand. So I hope it is clear what is a discrete random variable and how do we find it, right? And how do we construct a probability distribution table? Now I'll take some questions. Let's do it. I'm doing this question. So let's take this question here. So what this question is saying, a magazine store recorded the number of magazines purchased by its customer in 1 week. So basically, 1 magazine, 2 magazine, 3 magazine, 4 magazine, and 5 magazine. And if you see here, they've already defined your discrete random variable x be the number of magazines. So how much is the number of magazines? It is 0, 1, 2, 3, 4, or 5. So I'll make a nicer table again. Let's make it 1, 1, and 5. Let's take it. Right. So x, so state the possible values of x. So possible values of x is so possible values of x is 1, 2, 3, 4, 5. 5 magazines. A is either it can be 1, 2, 3, 4, or 5. So let's come to B part. Construct a probability table for x. What do we mean by probability table? This is the probability table. So x is equal to 1, 2, 3, 4, 5. Then probability of x. So probability of 1 is 0 0.23, 23%, which means, and 0.38% is 0.38, 21% 0.21, 13% 0.13, and 5% 0.05, right? Construct a probability table. So this is done. And how do you graph the probability distribution? It's very simple. You need to take this, or the graph is this one. You need to take this graph, you make this graph, and you will mark x's here. So let's take it 1, 2, 3, 4, and 5. So for 1 magazine, it is 0.23. Let's take it here, 0.23. And then 0.38. So let's take it here, 0.38. 0.21 will be a little lower. Then I'll take 0.13. Then I take 0.05. So how you'll make it? You'll make a rectangle with 1 at the center. So 0.23. So it will be something like this, right? Then you have 0.38. So it will be something like this. Then 0.21, it will be something like, let's say, this. Then it will be 0.13. It will be like this. Then it will be 0.05. So this is my whole answer. Got it? So this is how you will solve. So state the possible values of x and construct a probability table for x, graph the probability distribution which I did, find the mode and the median. So mode is the highest possible. So 0.38. So my mode is 3. And median is like the 50% of the data. So 0.23 plus 0.38. How much it is? 1, 3, 2, 5, 6, 0.61. So 0.5 is less than this. So it lies in this thing. So my median is 2. I hope this is clear, right? Sorry, my mode is also 2 because the highest frequency is 0.38. Got it? So this is how you will solve these kind of questions. I'm doing more questions with you so that you will understand it better. Let's take the second question. I'll just take this question and then we will solve it. Once you will solve some questions, you'll be perfect with it. Yes. So now let's solve this question. Question 2, come here, and let's paste it over there. So they are saying my x is 1, 2, 3, 4. So again, what I'll do is I'll make this kind of a table. So this is my, I'm making a probability distribution table. This is my x, this is my 1, this is my 2, this is my 3, and this is my 4. So let's come to x, 1, 2, 3, 4. So then probability of x, I have to put 1 here because the probability of x depends on x. So probability of 1 is equal to 1 plus 1 over 34. I'm not cutting it. I'll just write 2 by 34. So this is 2 by 34. This is 5 by 34. This is 10 by 34. And this is 17 by 34, right? So what do you mean when we are saying it is a valid probability mass function? Because the sum of probabilities should be 1. Got it? So this means 2 over 34 plus 5 over 34 plus 10 over 34 plus 17 over 34 is equal to 1. So that means it is a valid probability density function. Got it? Let's move to question 3rd. Here, right? So this question is saying consider the probability distribution. Okay, perfect. Find the value of a. So it is very easy. You just have to do 0.1 plus 0.25 plus 0.45 plus a is equal to 1. So a is equal to, first I can calculate this. So 0.1, 550, carry 1, 4, 2, 6, 7, 8. So 0.8 plus a is equal to 1. So a is equal to 0.2. Right? Is x a uniform discrete random variable? Okay, I'll tell you one more thing. What is a uniform discrete random variable? When the probability of everything remains the same. But here the probabilities are different. So it is not a uniform. It is not a uniform discrete random variable. It is a discrete random variable, but not a uniform discrete random variable. So state the mode of the distribution. Mode of the distribution is maximum frequency or maximum probability, which is 0.45. So mode is equal to 2. Perfect. Then let's talk about the D question. D part, find probability of x greater than equal to 2. So basically greater than equal to, so 2 and 3. So 0 point probability of x greater than equal to 2 is equal to 0.45 plus a, which is 0.45 plus 0.2, which is 0.65. So this is my answer, right? Let's move to the next question. Let's do question 4. Let's see what we have here. 100 people were surveyed about the number of bedrooms in their house. 24 people have one bedroom, 35 people have. So first, what we need to do is we need to create a distribution table. So let's make this first. Or let's delete it and make it again. This, let's take this and this, right? Perfect. Now I'll take a straight line, divide it into two, and then I have like 1, 2, 3, and 4. So I'll make 1, 2, 3, and 4, right? So first I'll write x probability of. So if I have, how many people are total? 100 people. So 1 bedrooms, 2 bedrooms, 3 bedrooms, 4 bedrooms, right? So 24 over 100, 35 over 100, 27 over 100, and then 14 over 100. Got it? Let x be the number of bedrooms a randomly selected person has. State the possible values of x. What are the possible values of x? 1, 2, 3, 4. We construct the probability table for x, which we have already constructed. Find the mode and median of the distribution. So mode is the highest possible frequency, right? So highest possible frequency is, as I can see, 27 over 100. So mode is equal to 3. Perfect. Now we will see it should be added to 0.5 class. So if I'll add probability of 1 plus probability of 2, then it will give me 55 over 100, which is 0.55, right? So which is greater than 0.5. So my median is, I hope everything is clear, whatever we have done till now. If I'll definitely be attaching a worksheet in the description box. And again, if you find any doubt, you can definitely contact me. And in the meantime, please subscribe to my channel.